This is called the slope-intercept form. Slope. This whole thing is the slope-intercept form. Slope-intercept form. This is baby stepping us into this 8th grade stuff we're going to start working on next week. Baby steps. So, starting here, the thing you need to know is we're going to do a crash course review over M, which is slope. Second period told me that y'all know what slope is. Or y'all have heard the word slope before? Okay. So this is slope. M stands for slope. Why? I don't know. I'm sure there's a good story. So, the easiest way to remember how to find slope, 1, slope is the measure of the steepness of a line. So if a line is going up really fast, you wanted to say, how fast is it going up? Or if it's not going up at all, we want to be able to put a number on that. There are all kinds of laws. The FDA, nope, that's Food and Drug. The people who have to deal with the safety of like buildings, if you are in a wheelchair, there are laws to protect you. Like the ramps outside of buildings have to be a certain slope to be legal. I can't remember what it is. But there is a law. And so those guys that build those ramps have to be within this guideline, or the building can be sued, and then they have to go tear up the ramp and rebuild it. Because imagine, if you're in a wheelchair and the ramp is really steep, like you can't roll up that. Like it's going to be really difficult for you to push yourself up the ramp. So they're really slow and steady. It's got to be slow and steady. So that's all about slope. We find slope by measuring the rise of the line over the run. This is the most popular way. Rise over run. When I was in 7th grade, this is how we learned slope. Rise over run. Now, the mathematical, the rise is your up and down. What axis is up and down? X or Y? Y. So I am going to measure the change in Y. This is delta. It stands for change. So how much is Y changing over how much is X changing? Y's over X's. What else have we done lately where you put Y over X like that? The K. Yeah. K, constant of proportionality when you put your Y over X. Now, this one's going to be a little bit trickier because we can't just do Y over X. We have to do the change in Y over change in X. Y over X works if it's a 1-step. This works because there's 2 steps now. So, there are 4 types of slope. I'm going to try to draw this better this time. We read from left to right. So, I call it the pencil test almost. So if you put your pencil on the paper and you move it from left to right, if the line is going up, that's a positive slope. If you're moving your pencil from left to right and it goes up, that's positive. If it's going down, that's negative. So that line is going down from left to right. So it is a negative slope. The next one I like to think of is like the marble test. If I have a marble, just a regular old marble, glass marble, if I put it on a perfectly flat surface, imagine that it's perfectly flat, and I put the marble right in the middle, is it going to roll? No, it will not roll. It will have 0 movement. So, 0 movement is a flat surface. absolutely flat. It will not roll. If I have a perfectly vertical surface, and I take that normal marble, and I put it on the surface, is it going to stay on the surface? No. Is it going to even roll on the surface? No, it's just going to fall. So there is no slope. That's called undefined. So you have your positive slope, negative slope, zero slope because there's zero movement, and then your undefined, and it's not, when it's undefined, it has to be undefined or does not exist. Yes? Because it's supposed to. It helps you remember all the different positive, negative. It's a little guy with his little skinny face, his winky straight face. Slope man, slope dude, whatever you call him. So if you think about this up and down, is there any rising on a vertical line?
No.
Does it go up and down?
No.
From here to here, did it go up? Yes, it does go up and down. There is rise. Does it run from left to right at all?
No.
No, so there would be a 0 on the bottom. Can you divide by 0? That's why it's undefined. This one going left to right. Is there any rising? Does it go up and down at all? No. Is there running from left to right?
Yes.
So I would be 0 divided by something. And that's 0. You can take nothing and share it with people, but you can't take something and share it with no one. So those are all the slopes. B, the other part of our equation. This B stands for y-intercept. That's where the intercept from slope intercept comes from.
B equals y-intercept?
The B stands for y-intercept, yes. If you intercept something, imagine I'm throwing a football, and somebody that I did not intend for it to catch catches it. What do you call that?
Interception.
An interception. Generally, I'm thinking I'm going to throw it this direction, and somebody's going to come across and they're going to take it out of the air. So you're intercepting something. The y-intercept is where the y-axis intercepts the line. So if you have your graph, if your line is just minding its own business, doing this, if here's my line, the y-intercept is right there. It's where it crosses the y-axis. Crosses y-axis. Now, sometimes there's a very easy way to figure it out. What is x for that dot? 0. So when x is 0, whatever that y is, this is when x equals 0. Because whatever y is, x is 0 because it's on the y-axis. All right. Example time. When you have a table, x is always going to be on top. So we're going to do x and y. My x's are going to be 2, 4, 5, 6. There is no rule that says it has to go in order. There is no rule that says it has to be constant. All this table is doing is showing me 4 points on a line. So this is going to be 8, 14, 17, and 20.
So you can't do something like 14, 13?
If it fell into the equation, sure. So the first thing I need to do, here's my table. These are my coordinates. I could take these and graph them. I'm not gonna. Step 1, I need to pick 2 pairs. Pick 2, we're going to call them coordinates because that is what they are. Pick 2 coordinates. Are there any pairs that stand out to you that you would like to use? The beauty of this is it does not matter. They will all come out to the same. 2 and 8. What else? 6 and 20. So 2 and 8. 6 and 20. Okay? This part feels like magic to me because sincerely, you could pick, if anybody wants to try it, you can pick any 2. Doesn't matter. Pick 2. The next part. How much does the y change? Step 2. How much did y change? So from 8 to 20, what is the change? How do you figure change? 12. How did you get 12? Yep. So 20 minus 8 equals 12. So 12 is my delta y, because delta means change. Step 3. How much did x change? How much did x change? Since I did 20 minus 8, I have to do 6 minus 2. You have to go in the same direction, which it comes out nice for this. So what is 6 minus 2?
4.
4. So 4 is my delta x. Last one, step 4. Delta y goes over delta x. So delta y was how much? 12. And delta x is how much? And what is 12 divided by 4? So my slope is 3. M equals 3. Slope, M. If it doesn't come out even, keep it a fraction. Don't make slope decimals. It doesn't work well. Since it's rise over run, if it says 2 over 5, I can go up 2 over 5. Up 2 over 5. Up 2 over 5. But I can't like go up and over 0.4. That's harder to do. All right, last thing. So 3. This is my multiply piece. But what is 6 times 3?
18.
How much more do I need to get to 20?
2.
So my plus piece is plus 2. So y equals m is 3, x, and then plus the 2. Oh, sorry. There you go. 3x plus 2. Because 2 times 3 is 6, plus 2 is 8.
Oh.
4 times 3 is 12, plus 2 is 14. 5 times 3 is 15, plus 2 is 17. And then we already did that one. Okay, so here's my equation. Your multiply piece, and then your y-intercept piece. Not so much worried about y-intercept just yet. But this means that when x is 0, how much is y? 2. if you were to continue this pattern, so this is going up 2, and this went up, thank you. So if I go back 6, that's another way to see this. So if this is going plus 6, and this is going plus 2, if I go back 2, and I go back 6, that's another way to get your y-intercept b. When x is 0, y is 2. That's your equation.